This is the demonstration class, and today I will take the class on sequence and series. Sequence and series. Sequence and series. There are three types of sequence which we will study about, because there might be a lot of sequence type, but we will study mainly three types: arithmetic sequence, arithmetic, geometric, and harmonic. Okay, these three types of sequence we will study about. Okay, arithmetic, geometry, and harmony. Then what is arithmetic sequence? Arithmetic sequence. Arithmetic sequence. Arithmetic sequence. When the next term is determined by addition or subtraction, where the next term is determined, next term is found out by addition or subtraction of some constant number, then that sequence will be called arithmetic sequence. Means, or if there is one, and by adding 2 you will get 3, 2, 5, 2, 7. This will be arithmetic sequence. This will fall under arithmetic sequence, because every next term has been found by adding 2 to the previous term. Adding 2 to the previous term. Adding 2 to the previous term. Okay. When the next term is found out, next term is determined by adding or subtracting some fixed quantity, okay, in the previous term, then that sequence will be called arithmetic sequence. Means 1, -1, -3, -5. This will also be in arithmetic sequence, because every next term has been found out, has been determined by subtracting 2 in the previous term. 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 Okay? And this has been found out by adding 2 in the previous term. Okay, next arithmetic sequence where next term is determined by adding or subtracting some fixed number in the previous term. Arithmetic sequence where next term is determined by adding or subtracting some fixed number in the previous term. Next term plus minus something, some fixed quantity, some fixed number will be previous term, plus minus some fixed, previous term plus minus some fixed number will be next term. Will be next term. When the sequence are arithmetic sequence. Okay? And geometric sequence. geometric sequence. Geometric sequence geometric sequence is completely different from arithmetic sequence. Here, in the case of geometric sequence, we get the next term by dividing or by multiplying the previous term with some fixed number, fixed real number or fixed number, any number. Let's say real number, whole real number is the okay, geometric progression. Geometric sequence means geometric sequence when the next term is determined by dividing or multiplying. When the next term is determined by dividing or multiplying the previous term by some fixed number other than 0. Okay. When the next term is determined by dividing or multiplying the previous term by some fixed number other than 0, then that sequence is called geometric sequence. Means 1, 2, 4, we are multiplying by 2 every term, every previous term. When you multiply by 2 will come out to the next term. Means 2, 1, 2, 4, 8, 16. Just multiply, even multiplying by 2 every term. When you multiply by 2, you will get the next term of that term, and in this way you are getting a sequence, and this sequence will be called geometric sequence. This one and other one by dividing each term by a constant, by a fixed number. Means 2, when you divide it by 2, you will get 1. When you divide it by 2, you will get 1 upon 2. When you divide it by 2, you will get 1 upon 4. Thus, up to infinite, it is coming under geometric sequence. It is coming under geometric sequence. It falls under geometric sequence. Means when the next term is determined by dividing or multiplying the previous term by some fixed number other than 0, then that sequence is called geometric sequence. And when the next term is determined by adding or subtracting the previous term by some fixed number okay, then that sequence is called arithmetic sequence. And in the arithmetic sequence 0 will be included, but in the geometric sequence 0 will not be included while you are dividing something, because you cannot divide some term by 0. So while you dividing, 0 will not be considered. Okay. But on multiplying, you can consider that will be very rare. So you can say that every next term, in general, you can say that every next term will be determined by dividing or multiplying the previous term by some fixed number, geometric sequence, and then harmonic sequence. What is the harmonic sequence? Harmonic sequence is nothing but the reciprocal of arithmetic sequence. Arithmetic sequence is nothing but the reciprocal of arithmetic sequence. And what is the meaning of reciprocal? Reciprocal means whenever you divide some one by some number, then that will be called reciprocal of that number. Means reciprocal of x will be 1 upon x. Reciprocal of any number will be 1 upon that number. Or reciprocal means reciprocal of arithmetic sequence will be harmonic sequence. Means if there is given something like that, a sequence in x1, x2, x3, this is in AP, okay, arithmetic sequence. This is in AS, arithmetic sequence. Then 1 upon x1, 1 upon x2, 1 upon x3. This will be in harmonic sequence. This is harmonic sequence. This will be under harmonic sequence. If something is in arithmetic sequence, then reciprocal of that terms will be in harmonic sequence. Okay, definition is over. Now we will come on the problems. Next concept. And if we write arithmetic sequence, any sequence, if we write any sequence with some operation on it, means plus, minus, anything, then that will be called arithmetic series. Means let A1, A2, A3 are in arithmetic sequence, then A1 plus A2 plus A3 plus A4 will be called arithmetic series. Okay. A1, A2, A3, A arithmetic sequence, then A1 plus A2 plus A3 plus AN will be called arithmetic series. Sequence. Okay. And the same is the case. The same case will be applied to geometric and harmonic sequence also. Same thing will be applied. All the three sequence. Okay. And if some sequence is given, then you will be asked to find out the nth term. Means any term, any general term. How will you find out that? And what are the required information to get out that? Yeah, to find out that. So let something A1, A2. This is in arithmetic, and sequence is also called progress. In which manner it is progressing. In which manner something is progressing is called sequence. In which manner? What are the means of progressing the term? What are the basic? What are the things on which the sequence depends? What is the basic thing behind that? So arithmetic progression and arithmetic sequence both are same. How they are progressing. Okay. How they are progressing. Arithmetic sequence and progression both are same. So you can see arithmetic progression here. Arithmetic progression. This is under arithmetic progression. Then and you are being asked to find out the nth term, means Tn. How will you find out it? How will you find it out? Then there is a way to find out this. Means arithmetic progression. A plus B, A plus twice B. These are a arithmetic progression, isn't it? Where B might be positive and negative both. D might be positive, negative number. Okay? Means you can add or subtract something, some fixed number. Okay? Means in the previous term. Means here you are adding D plus D plus D, A plus D, A plus D, A plus D plus D, A plus 2D. In this way, this is progressing. So it is called arithmetic progression. Actually, the manner of progression is arithmetic. And in this way, what do you see? First term is A. You can write it A plus 1 minus 1 into D. Second term is A plus D. You can write it A plus 2 minus 1 into D. Means just in the term of this number which is coming in the required term T2. Means 2 minus 1 upon D and into D. Third term will be A plus twice D. You can write it A plus 3 minus 1 into D. Okay. In this way, you can write nth term. Nth term will be A plus n minus 1 into D. Repeat. This n minus 1 into D, this 3 minus 1, this 2 minus 1, this 1 minus 1. Okay? What did you find out here? Tn, nth term. Nth term. Here nth term is A plus n minus 1 into D. Nth term is A plus n minus 1 into D. Okay. Okay. Fine. Now, what should we find out? What should we find out? मुझे क्या निकालना चाहिए? Nth term हो गया. अब मान लो कोई arithmetic progression है. Let us say some sequence are in arithmetic progression. Okay. There are some arithmetic progression given to you. Okay. This one. A1, A2. This is it, arithmetic progression. And now you are going to add all the n term. Means if there is given some arithmetic progression, then you will be asked to find out the summation of all the term. In that case, you will find out summation of all the term. You will find out. How will you find out? A1 plus A2 plus A3 plus An. This will be sum of n term. Sum of n term. Okay. Sum of n term. And what do you see? While you see some arithmetic progression, what do you see? You will definitely notice that first term and last term summation second term and second but last term means the second term from last. This summation is all are equal. All are equal. Okay, means sum of n term. Okay, then if 1, 3, 5, 7, 9, 10, 10, 20. Yes. And क्या है? Number of term. कितना term है? ये 5. तो 20 होता है. कैसे 2.5 25 होता है. Good. Yes. We have got the x. We have got the actual region. How do you to 10? Okay. Okay. Here, just by we can try. Means just by trying out this, you will find out the sum of n term. Means every you can take any arithmetic progression. Means 1, 3, 5, 7, 9. These all are in arithmetic sequence. Arithmetic sequence. Then first term and last term. Actually, this is the only. These are the only terms in arithmetic progression. Let us given these terms. Okay. Then first term, last term 10, summation 10. Second term and second and last term 10. Means what you see, every term which is equidistant from first term and last term, summation of this term is always constant. Always constant. So there will be, if there are only 4 term, 2 term, 4 term, then n upon 2 multiplied by first term plus last term will be the summation, isn't it? Means leave it 9. No, actually take another example. 1, 3, 5 and 7. Then 1, 7, 8, 3, 5, 8. Then what do you see? The number of term, every first term and last term means this summation. How many times it comes? It comes n upon 2 times, isn't it? If there are n elements, then this pair comes n upon 2 times it comes, isn't it? If it is coming n plus n upon 2 times, then summation will be n upon 2 times that number 8. Means 4 by 2 into 8, 60. 7, 5, 12, 3, 15, 160. It's really, you just add it, you will get 60. Means there must be the definition like that, n upon 2. And this one, first term plus last term. First term plus last term. Means n upon 2, a plus l. There must be definition like that. If you just see it minute, if you see some minute details, and if you see it very carefully, then definitely you come to the point that first term and last term summation will always be first term and last term. means there, if there are n term, then there will be n plus 2 couple of the same quantity, same fixed quantity. Then if you multiply n upon 2 into that same quantity, then summation will come out. Summation will be summation, that number will be summation. We will get the summation. So n upon 2 first term plus last term. And first term is a and last term is a plus n minus 1 to b, means n upon 2 twice a plus n minus 1 into b. Okay? And we imagine, we just conceive that yeah, it's okay. If there are n term, then n plus 2 term, n plus 2 couples will be there. In n plus 2 pair will be there, where each pair will sum up to add up to a fixed quantity, a fixed number. Okay? Okay? Means first term and last term, 10. Every second term means equidistant term from beginning and end. When we add equidistant term, then you will get a fixed quantity which is first term plus last term. If we add first term, last term, whatever you are getting, that number will be fixed. While you add the equidistant term from beginning and end. Okay? Then means you are getting n upon 2 pairs. Okay. If n is even, then it's okay. And now we are getting odd term. N is odd. Then what will happen? Okay, we can think like that. But in that case also, what do you see? First term, last term, 2, 10 and 1, 5 means total summation 25. And if you put these values in this formula, okay, n upon 2 twice a, n upon 2 first term plus last term. So n plus n upon 2, and what is n here? 5 upon 2 first term, last term, 10 to 5, 25. What do you see? It automatically comes out to be 25. It is giving the exact result. So the conclusion we have reached that summation will be this. The conclusion on which we have reached is this. The summation will be this, because this is true in every case. Every case, in each case, either in even and in odd, in both cases this is true. So we can take it as a general formula to find out the sum of n term. Sum of n term will be n upon 2, and you just put it a plus l. You easily remember it, a plus l, and or you can write it twice a plus n minus 1 into d. Okay, sum of n term. This was just by careful observation you can write it, but there is a method also by which you can find the sum of n term. And what is that method? I will show you that method so that you can find out the sum of n terms with a procedure, with a method. Okay. 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 If you are given just procedure to find out sum of n terms. Okay. Sum of n term. Okay. T1 plus T2 plus T3 up to Tn. Again write it, sum of n term is equal to, just write it by actually by moving it one term forward. Means write it from here, T1 plus T2 plus Tn minus 1 plus Tn. Means just move one term ahead and write it. Then okay, then when you subtract it, what would happen? When you subtract it, what would happen? This would be equal to 0 and this would be equal to this one, minus minus, every term will be minus, means T1 plus T2 minus T1 plus T3 minus T2 and lastly Tn minus 1, okay, minus Tn, okay, minus Tn, this is minus T1, no, this is T1, okay. Then what do you get? T1 minus Tn, T1 minus Tn plus 1 to n minus 1. How many times it would come? N minus 1 times. N minus 1 into D. Because T2 minus T1, T3 minus T2. What is this? Common difference. This is T2, this is T1. T2 minus T1 will be D. T3 minus T2 will be D. Isn't it? Then it comes out to be n minus 1 to D. So that you can write here that Tn T1 minus Tn, T1 minus Tn, A minus A plus n minus 1 to D plus n minus 1 to D is equal to 0. Okay. Offset. We are going to find out sum of n term, and we just integrate with nothing. So there is no way to find out the n term solution. So just what we do, this comes out to be Tn is equal to Tn, isn't it? So this is nothing. This is nothing. So no. Okay, twice Sn. Just multiply it. Okay? Twice T1, twice T2, twice. Okay? Then what happens? This will be equal to minus Sn. No, minus Sn will be equal to T1 and T2 minus 2T1. T3 minus 2T2, and thus is coming out to be like that. Okay? Then T1 minus 2Tn, T1 minus 2Tn. plus this would come out to be T2 minus T1 was D. If T2 minus T1 is D, then T2 minus T1 will be definitely minus D, isn't it? Yes, 3 minus 2, 1. Yes, D upon 2, isn't it? It will be D upon 2. Is it okay? Is it right? No, it's not right. Just you have to pair up, and there is no way. That might be lengthy. That's why I'm telling you that just pair and write n upon 2 a plus l. First term plus last term. This is the summation of arithmetic progression. Okay. If it is possible, or if it is easier, procedure is easier than this method, then definitely I will discuss that in the next class. Okay. Come to the point. Arithmetic, geometric, and harmonic progression. Okay. Now we are going to find out arithmetic mean, geometric mean, and harmonic mean. Let us say there are two numbers A and B. You have to find out arithmetic mean. Arithmetic mean between these two numbers. Then how do you find out arithmetic mean between these two numbers? Between any two numbers. There are two numbers A and B. Arithmetic mean will be A plus B upon 2. Why and how? Actually someone would raise question that how did it happen? Then you can see here, if this is first term T1, this is second term, this is third term, definitely T2 minus T1 will be equal to T3 minus T2. This is the basis of arithmetic progression. Every two pair of term will give a fixed number upon subtracting the lower term from higher term. So A plus B upon 2 minus a will be equal to b minus a plus b upon 2. That implies a by 2, a minus b by 2 will be equal to b minus a upon 2 into a b minus a. Okay, what do you see? Here it comes out to be b minus a upon 2, it comes out to be b minus a upon 2, means both are equal. So this is the arithmetic mean. Arithmetic mean between any two number is sum average of that two number. Those two number. Average of those two number is arithmetic mean. And geometric mean okay. Till now we haven't covered summation of geometric series or nth term of geometric progression. So we first cover that part, then we will come to geometric mean. Okay. AR square, AR n minus 1. This is geometric progression. This comes under geometric progression because any ratio of any two term will be equal, any two term. A and AR ratio, higher term upon lower term, will be equal to AR square upon AR. Ratio of any two consecutive term will always be equal. Will be equal to R, common ratio, and this is called common ratio. Common ratio of geometric progression. Okay. And in the case of arithmetic progression, subtraction of any term, any consecutive terms, subtraction of any two consecutive terms are always same, which is equal to D, which is the common difference. A plus D minus A, subtraction of any two term, higher minus lower, will be D, will be T3 minus T2, will be Tn minus Tn minus 1, common difference. And this D will be called common difference. Common difference. Okay? Now come to this point. Common ratio of GP, this will be called common ratio of GP. Okay? Now, okay. This is first term, this is second term, this is third term, and so on. And this is nth term. So Tn will be AR n minus 1, because here in this first term R's power is 0. 0 to n minus 1 means n term. 0 to n minus 1 means n term. Means this is n term, and nth term is AR n minus 1. Okay, this is nth term. Now we will add these terms so that we could find out summation of n term. Okay. ये आपका जीपी में है, तो सम ऑफ n टर्म क्या होगा, a प्लस ar प्लस ar स्क्वायर प्लस 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 ar n माइनस 1, ठीक है। ओके, and multiply this Sn by r Sn will be equal to, just write it one place ahead of the first series, means this will be ar plus ar square, here n minus 1 term will be ar n minus 1 and nth term will be ar n, because we are multiplying by r, isn't it? Now subtract these two cells. Okay. Now subtract these two cells. What do we get? Sn minus rsn will be equal to, this all will become negative, means a ar square, all term will be cancelled out except these two terms, a minus ar n. Okay, 1 minus r, Sn will be equal to a 1 minus r to the power n, then Sn will be equal to a 1 minus r to the power n upon 1 minus r. Okay, we have found out summation of n terms in geometric progression and n term. Okay, now we will find out the same thing for, no, actually nth term of harmonic progression. Okay, we do not need summation of n term in harmonic progression, harmonic sequence. We do not need, because this is not needed in our syllabus. So if some okay, a plus d, a plus 2d, this is in AP arithmetic progression, then 1 upon a plus d, 1 upon a plus twice d, this will be HP, harmonic progression. Okay, then the nth term will be a plus n minus 1 into d, this will be nth term. This is nothing needed and nothing is needed. Okay, this was all about arithmetic geometric harmonic progression, progressions basics. Now we will find out mean. We have found out arithmetic mean between any two numbers. Now we will find out geometric mean and harmonic mean between any two numbers. Geometric mean and harmonic mean between any two numbers. Let there are two numbers a, b, then we have found out that arithmetic mean will be equal to a plus b upon 2. Arithmetic mean is the average of those two numbers, and geometric mean is under root multiplication of both terms, under root AB. This will be geometric mean. And if we put all this in a sequence, then it will be geometric progression. Just like this will be arithmetic progression, just like the previous thing. Here A arithmetic means B. All three terms were in arithmetic progression. Here all three terms are in geometric progression. So the means T1, T2 and T3 means T2 upon T1 will be equal to T3 upon T2. This must be equal. So T2, what is T2? T2 we haven't found out. T2 square will be equal to T1, T3. Means T2 will be T1, T3 under root. Means Gm will be under root AB. Here, what was the same scenario? T2 minus T1 will be equal to T3 minus T2. T2 is the arithmetic mean. So AM minus T1 is equal to T3 minus AM. AM will come this side and this will become 2y AM is equal to T3 plus T1. Hence AM will be equal to T1 plus T3 upon T1 T3 plus T1. This way. Okay. And harmonic mean is nothing but whatever is a series in a harmonic progression, we will get those series in arithmetic progression first. Means if AB, okay, harmonic progression, here A, AM and B are in arithmetic progression, then definitely 1 upon A, 1 upon AM and 1 upon B will be no. Let harmonic A, B, that there are two numbers and harmonic mean is H. Then all three terms are in HP. So 1 upon A, 1 upon H and 1 upon B will be AP. HP is nothing but reciprocal of AP. So to find out anything in HP, we depend on corresponding AP. So this is it. AP. So 1 upon H is equal to 1 upon A plus 1 upon B upon 2 will be equal to twice AB upon A plus B. So H will be equal to A plus B upon twice A. Between any two numbers, A plus B, shift A plus B upon twice AB. So H will be twice AB upon A plus B. Okay. So this will be harmonic mean. Twice AB upon A plus B. Between any two numbers, harmonic mean will be twice AB upon A plus B. Okay. Now let us do some problems. In the same way, we can find out m arithmetic mean, m harmonic mean, and m geometric mean. Because if there are two numbers a b, then n arithmetic mean will be a1, a2, a. Then all will be in a b. In this way, we can find out a1, a2, a3. Okay. just similar to our previous method. Okay, you can find out an arithmetic mean or an geometric mean or an harmonic mean between any two number, but that's not much more important, so I am leaving that part. And now we are coming to the problems, because problems are much more important than anything, because only problems comes in exam. So only problems come in exam, theory doesn't come in exam. So arithmetic mean, question number first, find out summation of following series. ऐसा दिया हुआ 1 + 3 + 5 + 7 प्लस कुछ, ठीक है, ऐसा दिया हुआ है। ये आपको दिया हुआ है कि ये जो है 25 टर्म का 25 टर्म समेशन क्या होगा। आप क्या करोगे, इसका सम क्या होता है n/2, तो 25 है, मतलब 25 टर्म है, 25/2 मींस ये n का वैल्यू दिया हुआ है 25/2 फर्स्ट टर्म प्लस लास्ट टर्म, बिकॉज these are arithmetic series. फर्स्ट टर्म 1 और लास्ट टर्म 25, मतलब 1 + 25 - 1 × common difference is 2. This will be 25/2, 1 + 1 + 48, 25 × 25, 625. Okay. And here given 1, 2, 4, 8 up to 16 term. Okay. Then how to find out? These all are in geometric progression. These are in geometric progression. So 1 + 2. This is geometric progression, geometric series. When we are adding, this will be geometric series. 1 + 2 + 4 + 8 up to how many term? 16 term. Means n times n term. n is equal to 16. Okay. Summation is a 1 - r to the power n upon 1 - r. A is 1, 1 - r is 2, to the power n is 16 upon 1 - r is 2. Means this should be written like that: 2 to the power 16 -1 upon 2 - 1, isn't it? Is equal to 2 to the power 16 -1. This is the answer. Okay. Now you are given question number 2. Find out question number 3. We have done already 3 questions. No, 2 questions. Now it is question number 2. Find out nth term of following series. Nth term is 25th term. 25th term. ठीक है, पहला आपको दिया हुआ है 1, 5, 9, 13 और दूसरा दिया हुआ है 2, 4, 8, 16। ये आपका ईपी है, अरिथमेटिक प्रोग्रेशन, और ये आपका क्या है, जीपी, ज्योमेट्रिक प्रोग्रेशन। ठीक है। और तीसरा दिया हुआ है 3, 5, 7, 9, 11, ऐसा दिया हुआ है 1/3, 1/5, 1/7, 1/9, 1/11। तो ये क्या है आपका हार्मोनिक प्रोग्रेशन है। सभी का क्या निकालना है, 26 का। तो इसका 26 का क्या होगा, जो अरिथमेटिक प्रोग्रेशन में है, TM क्या होता है, T25 इज इक्वल टू ये क्या है यहाँ पे 1 प्लस n minus 1, 25 minus 1, 24, कॉमन डिफरेंस कितना है, 5 minus 1, 4 will be equal to 96, 97. This will be the answer. Okay, in this case में 25 टर्म क्या होगा, ये होता है फर्स्ट टर्म कॉमन रेशियो 4/2 टू द पावर n minus 1, n कितना है 25 minus 1, 24 will be equal to 2 to the power 25। ये आंसर हो गया। इस केस में n टर्म क्या होगा, T25 हार्मोनिक प्रोग्रेशन में है, तो इस केस में क्या होगा, जो अरिथमेटिक प्रोग्रेशन में है 1/, जो अरिथमेटिक प्रोग्रेशन में 3, 5, 7 इसका डिनोमिनेटर, तो उसका nवां टर्म 1/Tn, तो ये क्या होगा 1/, ये क्या T प्लस n minus 1, 25 minus 1, 24, D क्या 5 minus 3, 2 will be equal to 1/51. This is the answer. Okay. Okay, and now last but much more important, which often come in standard competitive examination, relation between arithmetic mean, geometric mean and harmonic mean. What are the relation between arithmetic mean, geometric mean and harmonic mean? Relation between arithmetic mean, geometric mean and harmonic mean. Okay. If there are two numbers A, B, the arithmetic mean will be a plus b by 2. Arithmetic mean will be a plus b by 2, and geometric mean will be root under AB. Harmonic mean will be twice AB upon A plus B. Fine. Now what do you see? What do you see? That arithmetic mean is always greater than equal to geometric mean, and geometric mean is always greater than equal to harmonic mean. This is the relation. How? Okay. You have to prove this one. Now how it can? How did it come? Then arithmetic mean a plus b by 2, and geometric mean root a. Okay. Okay. You have to prove arithmetic mean minus geometric mean is greater than equal to 0. Isn't it? Arithmetic mean greater than equal to g, and geometric mean means arithmetic mean minus geometric mean is greater than equal to 0. Means a plus b minus twice root ab greater than equal to 0. Root a minus root b upon whole square is greater than equal to 0. Isn't it? Whole square of anything will be greater than equal to 0. So arithmetic mean is greater than equal to geometric mean, and the similar way you have to prove geometric mean is greater than harmonic mean. Geometric mean is root AB. If this is greater than equal to harmonic mean, twice AB upon A plus B, okay, root under AB. If this is greater than that, root AB, you can divide by root AB, means 1 greater than equal to twice root AB upon A plus B, and you can subtract same number both sides, means 1 minus 1 will be greater than equal to 1 minus twice root AB upon A plus B. Isn't it? Means if you do minus, then sign will change, less than equal to, and if you add something, means you are adding 1 both sides, then sign will remain as it was before, and sign will remain constant. Sign will not change. Okay, means 0 greater than equal to A plus B minus twice root AB upon A plus B, means root A minus root B whole square is greater than equal to 0. The same case arises, which we have discovered while we were doing arithmetic mean is equal to greater than equal to geometric mean. Same thing has come. So the geometric mean will always be greater than harmonic mean. Arithmetic mean will always be greater than geometric mean. Okay, this is very much important relation. So okay, now I'm closing this session because it has eaten my all the time. Now my time is over, so I'm closing this session. Thank you very much, and if you like it, please comment, share, and subscribe.